Hello friends, in this video we will learn regarding the measurement of torque and shaft power. What is torque? Torque is a multiplication of force and a perpendicular distance or a radius from a particular point. The measurement of torque is associated with the determination of power developed or consumed by the rotating part. The principle to measure the torque is, friends, by generating an opposite force or by absorbing or by say transmitting. So there are different methods to find out the torque. So you can see here there is a classification chart or classification table for the torque and power measurement technique. So mainly there are three different types of torque measuring parameters. The first is absorption type, second is transmission type, and third is driving type. Now absorption type means what? In this type of dynamometers, the energy produced by the engine is absorbed by a frictional resistance of a brake and finally transformed into heat. It means this kind of dynamometer is the device in order to find out the power output of a particular machine or engine. Absorption type dynamometer means whatever the power is generated or whatever the torque is generated, it is absorbed by the dynamometer and released in terms of heat by generating a friction. So Prony brake dynamometer, block type and bend type is one of the type of absorption type dynamometer. Rope brake dynamometer, hydraulic dynamometer, and eddy current type dynamometer. In our syllabus, friends, we are having brake rope dynamometer and the Prony brake dynamometer and rope brake dynamometer. So we will see them. Hydraulic dynamometer also is a dynamometer, a type of absorption type dynamometer, and eddy current type dynamometer is operated electrically. The second type is transmission dynamometer. In this type of dynamometers, the energy is not wasted into the friction, but energy is converted into the surrounding in a useful mechanical or electrical form. So the belt transmission dynamometer, epicyclic train dynamometer, torsion dynamometer, and strain gauge dynamometer are the example of this. The next is driving dynamometer. In this type of dynamometer, the power producing or absorbing device whose power to be measured is coupled with an electrical generator or an electrical motor. The motor or generator measures its power and also the supply energy to the operate the tested device. This type of dynamometer is employed with a pump and the compressor for determining their performance. For example, electrical cradle dynamometer. Friends, this is a Prony brake dynamometer and it is absorption type dynamometer. As we said, that whatever the power or energy is generated is being absorbed in terms of friction and released in terms of heat. So I'll show you the working of this. Now this is the flywheel rotating of an engine shaft connected to the engine. This is the spring loaded block, wooden block, and this is the kind of lever operated wooden block. Now you can see here some weight is applied here. This weight will pull down this lever in downward direction and pull this upper block towards the downward direction. Whatever the friction is generated, the rotation is in anti-clockwise. Whatever the friction is generated will be generated opposite to this motion, and whatever the amount of weight which is added here, step by step, slowly by slowly, will generate a braking effect on this, and it will try to stop the engine. At that time we need to measure the amount of weight which is applied with at some distance, leverage distance L, in order to find out the torque. So here is the formula in order to find out the torque. Torque is equal to the force into R. Now here F is equal to W, and R, the length from the center of the shaft, is equal to L. So the power is equal to W into T, torque into W. What is W? W is equal to 2 pi nt over 60. That is the angular velocity of the shaft. W is a, you can see here, angular velocity. So 2 pi n over 60. Substituting power is equal to 2 pi nt over 60,000 kilowatt. Here it is 1000, so it will be considered as kilowatt. If it is only 60, it will be considered as watt. N is the revolution of rotation of the shaft per minute. F is the frictional force. L is the length of arm, and W is the applied load at the end of the pump. So from this data, friends, we can find out the torque T for the Prony brake dynamometer. Now we'll also discuss the advantage and disadvantage of the Prony brake dynamometer. If we see the advantage, they are simple in the construction, less cost, and suitable for the measurement of all small power. This is applicable for all small powers. The disadvantage is the coefficient of friction is reduced due to wear out of the block. Hence, in the long run, dynamometer becomes unserviceable for the measurement of large power. Definitely, friends, there will be a reduction, or there will be a wear on the wooden block because of the resistance, and because of that the service life of the Prony brake dynamometer decreases. Again, due to heat generation or temperature rise, it also decreases in the coefficient of the friction, so cooling system is required for the dynamometer. Third, when the driving torque on the shaft is not uniform, this dynamometer is subjected to several oscillations. So it will be difficult to find out the particular value if the torque is not uniform on this shaft. So these are the disadvantages of the Prony brake dynamometer. Friend, in this figure you are seeing the rope brake dynamometer. In rope brake dynamometer, if you see the construction, on the one end of the rope is attached to a spring balance, and this spring balance is hanged at some fixed point. This rope is rolled out over a drum which is connected to the engine output shaft, and here some dead weights are there. Now, how does it work? These are the two cooling pipe. One is supplying cooling water in order to maintain the temperature, because when the flywheel is rotating, or this drum is rotating, the heat is generated between the drum and the rope. In order to reduce that heat and dissipate that heat quickly, the cooling water is circulated inside this drum. Whatever the weight W is acting here and the spring load which is there, the net acting weight will be taken as W minus S, the difference between the act which is acting downward and this is acting upward. So the torque, the force which is acting, will be taken the difference of W minus S, and this is the drum radius. This is the drum diameter shown D. So this is the drum radius, and here also the rope radius also is taken into the consideration for this. So you can see here, this is the formula. I told you that the effective radius in order to calculate the torque will be d plus d by 2, that is the diameter of the drum plus diameter of the rope divided by 2. Braking torque is given by T is equal to the tangential force into the radius of the wheel, where effective radius is taken, that is d plus d by 2. So brake power is given by 2 pi nt over 60,000 kilowatt, where T is substituted by W minus S into R effective. So this is how we can calculate the power, or also we can calculate the torque of the engine or system. Let us see the advantage and disadvantages of this brake rope dynamometer. If you see the advantage, simple in construction, it is more suitable than the Prony brake dynamometer, and it can be used for wide range of power. It can be used for a long test while little overheating and without requiring any adjustment. The disadvantage is less accuracy because of change of coefficient of friction of rope with the temperature, and cooling system is required. So these are the disadvantages of this.